Question 1. Solve each of the following equations. A, we have modulus 3x minus 2 equal to x. Since we have a modulus function, we have one positive equation and one negative equation. First one, we have 3x minus 2 equal to x. And the second one, we should have 3x minus 2 equal to negative x. Let's solve for the first equation, 3x minus 2 equal to x. We collect all the like terms together. 3x minus x equal to 2. 2x is equal to 2. X equal to 1. For the second equation, 3x, bring the negative x over, become plus x equal to positive 2. 4x is equal to 2. X is equal to 2 over 4, which is 1 over 2. B. Modulus 2x minus 3 over x plus 4 is equal to 5. Let's write down the two equations. The first one, 2x minus 3 over x plus 4 equal to 5. And the second one, 2x minus 3 over x plus 4 is equal to negative 5. Let's solve the first one. We multiply x plus 4 at both sides. We should get 2x minus 3 equal to 5 multiplied by x plus 4. We expand the bracket. We have 5x plus 20. Put all the terms with x at one side and the terms without x at the other side. Here we have 2x and 5x. I will bring my 2x to the right side so that I get a positive value for my x. Negative 3 minus 20 is equal to 5x minus 2x. Negative 23 is equal to 3x. X equal to negative 23 over 3. For the second equation, we multiply x plus 4 at both sides. We have 2x minus 3 is equal to negative 5 multiplied with x plus 4. We expand the bracket. We get negative 5x minus 20. For this one, we'll move all the x to the left side. So we have 2x plus 5x is equal to negative 20 plus 3. Simplify it, we have 7x equal to negative 17. X equal to negative 17 over 7. For C, we have modulus x squared minus 3x is equal to x minus 3. Let's write down the equation first. We have x squared minus 3x equal to x minus 3. And the second one, I write it here, so it will be x squared minus 3x equal to negative bracket x minus 3. Since this is a quadratic equation, we need to factorize it. Bring all the terms to one side. We have x squared minus 3x minus x plus 3 equal to 0. Simplify it. We have x squared minus 4x plus 3 equal to 0. Then we factorize the equation. X squared become x and x. 3, we get 3 and 1. Here we get 3x. Here we get 1x. In order to get negative 4, negative 1, negative 3. Negative, negative. And we also need to check negative and a negative will give us a positive here. Continue. X minus 3 equal to 0. X is 3. And the second one, x minus 1 equal to 0. X equal to 1. For the second equation, we need to expand the bracket. First, we get negative x plus 3. Again, it's a quadratic equation, so we move all the terms to one side. X squared minus 3x plus x minus 3 equal to 0. Simplify it, x squared minus 2x minus 3 equal to 0. We factorize the equation. X and x, 3 and 1. Here we have 3x, here we have 1x. In order to get a negative 2x, we have minus 3 plus 1. Minus 3x plus 1x. Negative and positive, we get a negative. We proceed. X minus 3 equal to 0, x is equal to 3. And the other one, x plus 1 equal to 0, x equal to negative 1. Question 2. Solve the following pair of simultaneous equations. We have y equal to x plus 3 and y equal to modulus x squared plus 2x minus 3. First, since we have a modulus y, we have to make them into a positive and a negative equation. The first one, we will have y equal to x squared plus 2x minus 3. And the second one is y equal to negative bracket x squared plus 2x minus 3. And by expanding it, we have negative x squared minus 2x plus 3. Here, we need to do two sets of simultaneous equation. The first one is equation 1 and equation 2, the first set. And the second one will be equation 1 and equation 3. So the first one, equation 1 and equation 2, what can we do is we equate them. Equation 1 equal to equation 2. Therefore, y is equal to y, x plus 3 is equal to x squared plus 2x minus 3. This is a quadratic equation. We move all the terms to one side. For this one, we'll bring all the terms to the right side. We have x squared plus 2x minus 3 minus x minus 3 equal to 0. Simplify the equation. We have x squared plus x minus 6 equal to 0. Then we factorize it. We have x and x. 6, we have 1 and 6 or 2 and 3. The combination we need is 2 and 3. You can see here, 2 and x, we have a 2x. 3 and x, we have a 3x. In order to get a positive x, we plus 3 minus 2. Plus 3x minus 2x. And we need to check negative and positive. We get a negative here. Then we continue. X minus 2 equal to 0. X equal to 2. And the other one, x plus 3 equal to 0. X equal to negative 3. For the second pair is equation 1 and equation 3. Equation 1 is equal to equation 3. X plus 3 is equal to negative x squared minus 2x plus 3. For this one, we will bring all the terms to the left side. So we have positive x squared plus 2x minus 3 plus x plus 3 equal to 0. Simplify it, we have x squared plus 3x minus 3 plus 3, we get a 0. Factorize it, we can take out the common terms, which is the x. We left with x plus 3 in the bracket. So we have x equal to 0, x equal to negative 3. Combining both set of answer, we have x is equal to negative 3, 0, and 2. And don't forget to find the y value. So now we substitute x equal to negative 3 into equation 1. You may substitute it into equation 2 or 3. We will get the same answer. But 1 is the easiest. So we do it with equation 1. Y equal to negative 3 plus 3, 0. First coordinate is negative 3, 0. Substitute x equal to 0 into equation 1. Y equal to 0 plus 3, which is 3. The second coordinate will be 0, 3. And lastly, substitute x equal to 2 into equation 1, y equal to 2 plus 3, which is 5. So the last coordinate will be 0, 5. Question 3. The function of f and of g are defined by f of x equal to modulus 2x minus 3 and g of x is equal to 2x plus 9 over 5 respectively. A. On a graph paper, draw the graph of y equal to fx and y equal to gx on the same axis for x is between -1 and 4. You may draw it on a proper graph paper, but here we will just sketch it. Let's prepare a table for fx. This table is for the value without the modulus, -1, 4, and we need the intercept as well. When x is -1, our fx will be -5. When x is a 0, fx is a -3. When x is a 4, fx will be a 5. And we also prepare a table for our gx without the modulus also. We have -1, 0, and 4. When x is -1, -2 plus 9, 7 over 5. When x is a 0, we have 9 over 5. When x is a 4, we have 17 over 5. Let's sketch the graph. -1, 1, 2, 3, 4. Let's sketch for the graph fx without the modulus. -1, -5, 0, we get -3, 4, we get a 5. This is the graph of fx without a modulus. For all the negative value, we have to flip it up. -1, we should have a 5, and we should have a 3 as our y-intercept. So this. So I'm going to erase the green one. So this is fx equal to modulus 2x minus 3. Now we sketch the graph of gx without the modulus. When x is -1, gx is 7 over 5, which is 1.4, roughly here. When x is 0, our gx will be 9 over 5, which is 1.8. And when our x is a 4, our gx will be 3 and 2 over 5, so it's 3.4, somewhere here. Join all the points together. And this is our graph gx, 2x plus 9 over 5. Part A is done. Part B. From your graph, find the range of values of x that satisfy the inequality 5 modulus 2x minus 3 is lesser or equal to 2x plus 9. Part B, we need to find this. 2x minus 3 lesser equal 2x plus 9. If you compare this inequality with the given information, you realize that it actually looks the same like our fx and gx. We just need to move the 5 to the right side. We divide it. We have modulus 2x minus 3 lesser equal to 2x plus 9 over 5. This is our fx and this is our gx. What we need to find is the range of value of x that satisfy fx is lesser than gx. For fx is lesser than gx, fx is the red color, gx is the green color. So we want to find the area where the red is lesser than the green. It will be this part. Starting from this point, up until this point. So we will have the range of value of x that fx is lesser or equal to gx. Because I didn't do it on a graph paper, I cannot read the actual value. I will just write x1 and x2 for these two intersecting points. If you are doing it on a graph paper, you should have the proper x value. So for this one, I will just write the x is between x1 and x2. So that's it for today's tutorial. Hope it will help you in your study. See you again in the next video.